Okay, looking at the program flow in the same program, you can kind of see what's going on. We're outputting several things, and this is a variable we created up here. So we're outputting members of the array, and then our coordinates out of this two-dimensional array. Then I'm starting to work with this vector object, which we define or declare right here. Now, you notice this thing in the end that tells me it's a template. So, a lot of objects in C++ are actually templates from the STL, the template library. So, we'll discuss templates later. But basically, this is a template of type int. So, we're creating a vector of ints with 3 members in it. Let's see what the I don't know what these parameters are, but that looks like the first member or something. No, it's not giving me any kind of IntelliSense isn't giving me any kind of feedback on this, so I'm not really sure. You can always look this up, but I'm not really sure. But I know there are 3 members in this thing. What this looks like, well, I don't know. This might be the first member, or well, it might be assigning member 3 equaling to 122. There's a vector object, you can see us calling it down here, but I was going to say there are several different types. There's a vector, but then you have a queue object, and then you have I think a stack object, and there may be one other, but they all behave similarly, in the sense that you can use them kind of like a stack. But a user-defined stack of your own. So this right down here, is us doing a cout, saying vector.size, so we can see what the size of the vector is as we created it at this point. And then we can go vec.empty, which tells us if it's empty or not. Vec at 0, so you can look at an element laterally, in a stack. Probably not just 0 either. But I'm not really sure with the at command. It may reposition the thing or something, but okay, and here you pop something off the back, and you go vector.size and then vector.back. It's giving us the I guess the end element, the final element. Then you can clear the vector stack. So vector.size, we're checking the size again, and we're pushing onto the back value of 200. So again, I think we're creating 3 initial variables, but let's go ahead and put this in debug. Mode and run it. So you can can't see what's going on in the window here yet, but go back over here. Okay, so anyway, now you can press F8 to step through a thing, but of course it's taking us to the template class. So we're going to step out of it. Shift F8, allow you to step over it, but that's a little bit of a tricky key combination. So I've got to step out again. Okay. Shift F8. Okay. Now it's got us down to here. Okay. Doing here. Huh. Well, that's weird. Okay, there we go. Vector size is 3. I don't know if we can. Yeah, I can't probe it. It's returning. False. Because it's not empty. It's giving us a size of 3. Now we're doing the back popped off of it. Okay, our first element is 120. Now I'm not quite sure what our last element was, because again when we created it, that 3 / comma 122, I'm not really sure what that did. Okay, and it's returned 2 from that last operation, from vector size. And now we're given vector.back, it returned 121. Now our vector.cleared, so it eliminated now our size is 0. Now we're going to push the value onto the back, so now size equals 1. And our final element is 200, because we just push that onto the back. So anyway, it gives you an idea of what's going on, but I want to actually probe this a little more deeply here. Okay, we got this at function. Let's see what that does. So let me copy and place this a couple of times, a few times in fact. Have a position 3, so okay, let me reset my breakpoint here. Put it here, and I'll press F5 to run it. Took it a while. Shit. Okay. Alright. So, let's watch the little window down here and see what happens. Okay, shift F8. Okay, vec size is 3. It's not empty. First element 120, second element 121, 122. Third element, you know, is giving us an out of range, so you can't probe it because this is an object. See, an array I could actually get away with that, but because this is an object, I can't do that. So let me close this in the vector library. Okay, but at any rate, this did prove, you know, that we can access the vector laterally. So even though we push and pop values off of it, you know, pop off the back. So I don't know if there's the last element. Let's see what. Okay, we got an assign method, and we got the back element, clear, empty, end. I wish they'd give you, you know, an actual English explanation of what it does. Erase, front, get allocator, insert, so we can actually insert a value somewhere. Might try that. Now, I don't know how this works. Let's see. Okay. Simple types integer. What? Where? Man, this fucking, you know, IntelliSense description they use is crazy, isn't it? Okay, I don't know if I got to specify where or if it just inserts it as a value. It's an overloaded function, so again, in its simplest form, you know, yeah, we can't just okay, apparently that's still not the way to use that command. So, you know, I'd have to look this son of a bitch up, but, you know, the point is that, you know, you can apparently, you know, insert values at it. God damn it. Now I should be able to probe the third element because there should be a size of 4 now, or there will be. So shift F8, you know, 20, 121. Now we're going to push a value onto it. Size is now 4. Okay, and a vector of 3 does give us that. Okay, now we can pop a value off. Well, actually I don't need to do that. So we can pop a value off. Okay, then we'll get the vector size, which is now 3, and then we can see that the last element is now 122. So then we clear it and change the size and everything. So anyway, that's kind of how it sort of works. But again, of course, you're going to have to look this thing up if you really wanted to use it for a practical purpose. But again, there's queues and there's stacks too that, if you really need such a thing, that may be a better option to compare them. I'll do more on this later though. So okay, now we're going to look at the modulus operator. That's a tricky one. A, B, and C are variable names, or variable definitions. So let's step through this and get down to where we're looking at this next section of code here. And so our vector stuff is done with. Now I just did a modulus operator. Okay. So A is 8. 4 is, or B is 4. So basically, it's taking 8, dividing it by 4, and it returns the remainder. Now, so if A is 8, the division is 2. Okay, but the remainder is 0, so it's going to put 0. Okay, I don't know if this applies to this. This statement here applies to this. This note applies to this or not. That comment. Now, A is 8, and C is 3. Now, 3 will go into 8 twice. But we got a remainder of 2. Okay. Because it's old style division, so don't get out your calculator and divide 8 by 3 and say, oh, the remainder is, what would it be, 8 divided by 3, say the remainder is 0.66, because that's not what we're talking about. Although, multiplying 0.66 by 3, will give you a close approximation, about 2, but let's see what it said, 0 and 2. But it is just giving you the integer remainder, so, because this is a, basically it's performing a division, okay, but, I think it's an integer division, in fact, but it's given us the integer remainder. So, again, it's just like if you're doing it in grade school, working it on paper, old style long division, and you get a remainder of 2. Well, that's what it returns. So again, that can be a little confusing, but the modulus operator is a very heavily used operator in C. You can do some neat tricks with it. So, and I'll kind of show you examples because we'll be getting into that later. Let's see. Now here we're going to talk about post-increment versus pre-increment. So anyway, post-increment value, let me go ahead and run that statement. You know, gave us 8, okay, for A, okay, or 9. So, you know, because we had A, alright, printed in that statement. Okay, and post increment value, then it basically post increments it. So it's given it, you know, we're printing A and then putting this text string out there and doing a post increment on the variable A. So 9 equals A post increment value 8. Bizarre. Because remember, A is equal to 8 originally. But see, A is now 9. So it's kind of interesting, you know, that it gives us 9 here, but 8 here. That's really strange. Because it's almost like it evaluates this first, applies it to here, and then forgets about it when it gets to here. That's really peculiar. But let's jump over this next statement here, and that should yield 9. So 9 equals A, but that is really strange that it works that way, and you got to be cognizant of that it's not usually a good idea, you know, to process your information inside of an operation that involves strings for that reason. Because, you know, Visual Basic, you'd never have something like that happen, but here you can. Like I said, there are a lot of little quirks to see that, you know, you gotta learn like this, and that's one of them. You know, that be careful about, you know, because it'd be better to actually post increment this outside of it, you know, outside of the statement, and go, like, for example, you know, kind of what we did here. You know, we did this as a, you know, had nothing to do with the text. You know, we did it outside the text, but, you know, like this, you know, we should have gone, you know, A equals post increment value, and then instead of doing an inline, you know, we did put this on a separate line, this plus plus A, and then we finish it up with an indel. So, you know, another cout statement. Okay, that would have produced a better result. Let's see if I do that down here. I probably don't. Okay, but here we're going to do a pre-increment version of it, but I don't know what to expect, honestly. You know, this 10 equals A preincrement value 10. So it does behave differently when you do the pre-increment, you know, as opposed to the post-increment. So, but I'm not really sure why we got this result still. That's backwards. You know, because it's like at this point, okay, you know, it does the post-increment. In other words, it's putting A, it's showing us a value of A, you know, equaling 8. Okay, and then it's post-incrementing it, but then it goes and processes the first value of the cout. So it's like its cout works backwards or something, you know, from right to left. You know, because down here, you know, when you're using our pre-increment, okay, you know, it's showing us the value here, because when the statement is called, it is immediately pre-incrementing it before it displays it. And then, you know, so it's already incremented, you know, by the time it displays here too. So this is really bizarre how it works, but, you know, if you think about it, you know, using pre-increment in a text statement would be the way to go if you're going to do it that way. Otherwise, you should do it outside of the statement and split the cout into two different couts, and do your mathematical operation in between. But But at any rate, so that's kind of how the pre-increment versus post-increment operation sort of works. But usually, you'll be using the post-increment, but sometimes in if statements and so forth, sometimes you might want to use the pre-increment because it affects, what the value is like on the first iteration and so forth. So okay, we're still running, but I went ahead and typed this in even though I haven't stopped the program. To better demonstrate what's going on here, because that's really kind of a cheesy way of demonstrating because of how that cout statement works. But basically, I'm going to print, let me just go ahead and, okay, yeah, I had to recompile my changes in there, but you can sometimes insert some code snippets while you're in the process of debugging. But you can see what the result we have here. Okay, that's the result of the last statement. Okay, so now I'm going to go ahead and step over this. Alright, so that shows us our fucking initial values. A is 10 and C is 3, right? Okay. Now let's do this post increment. I'm assigning A to C to being equal to C, but post incremented C. So in other words, A should be equal to 3 because it hadn't been incremented yet. Now we'll print the results, or see out the results. So it does. A is equal to 3 now, but C has been incremented to 4, so its value is actually 4 by the time it hits this statement. But 3 got assigned to A because we assigned C to A first and then incremented C. So in other words, post-incremented it. Okay, but now we're going to pre-increment. So, C is going to be incremented to, 5? And A will be assigned 5. So they both equal 5 now. So that's pre-increment. So that's a better explanation for incrementing than what the book tried to show me, because that really is confusing how that thing works, that cout statement. That just introduces an unnecessary complication into it. Okay, and the rest of this code looks like it's just covering the topics, me experimenting with it. So let's go see what it outputted. Okay, modulus of A and B. Well, we know A is now equal to 5, so A and B and A and C is 0, because 5 divided by 5 is 0. So A equals 5, B equals 4, and C equals 5, so that's the printout of our variables. So, A and B for 5 divided by 4, would give us a modulus of 1. And then we can say 5 equals post-increment value 5, 6 equals post-increment value 7. Again, that's going into that same confusing cout thing, which, kind of, I'm not sure if it makes any sense. Let's see how I did it here. So I said, this I think is actually doing what I said. Post-increment value A++. But see, we're couting A equals. Okay, so this is what I was talking about up here, that it should be a split statement, so it behaves more logically. And I guarantee you this probably didn't come out of the book. It might have, but who knows. But at any rate, so this is working like it should. It's telling us what A is, and then our post-increment value is A. So we're couting A, which we know equals 5, right? Okay. And but then we're post-incrementing it, so as you'd expect, our value hadn't changed yet, so it's printing out the post-incremented value because it's really 6, just like you see here. So a equals 6. So this is a better, treatment of it. Okay, now a equals 6, our pre-increment value is printing out 7, so a equals 7. So again, if that first statement would have been written like this, it would have made more sense, because that's how you get away from that, the way cout is processing the values there, which was confusing up here. Okay, now this is using the printf statement, which actually, even Chili was using printf in some of his recent code, so it's not like totally deprecated, but still it's a console only print function for the most part. So although I believe we were loading bitmaps in with it, and I might get to that segment in this. It's in current code. Let's see. Shit. I don't know where I put it. Hold on. Alright, this is a code that, we used to load bitmaps. And I know he was using printf in some of his code. And again, we'll probably get to some of the code I did, some of the console code Chili went through. And I think he was using printf. Again, I think he was using this because I was kind of watching one of his old series tutors for this. And I had to adapt it to work with the newer C. But he wrote that back in 2012, but again, on some of his new tutors he was using printf too, I believe. So to deal with file loading and stuff like that, but he's not using it here apparently. This is a different type of loading operation, but printf can be used to load files and so forth still. But this bitmap, I don't know if I want to go through this or not, but it's in the Fardenoid program. Our solution somewhere, but you can't tell where it is just from here. But it's in Fardenoid. Yeah, which is right here, and you can tell where it is. It's source users, frig, source, repos, Fardenoid, if you ever use it. And this is the program that we're going to be writing here in a little bit. I'm going to write my own version of it from scratch, but still using Chili's framework of the bitpixel function. But anyway, that's where the Fardenoid is, and that's where this code is. And I'll show you what it does real quick. It just loads a bitmap onto the background. Just like this, this is one of the icons I loaded up, so, so anyway, I had to modify the code quite a bit to get the, to get it to display, but I'm reading a BMP file. Anyway, yeah, but again, he basically just creates these structures. Okay, and he got this off the internet on some site. So there's two structures involved in reading a bitmap file, and then he creates this structure for his use, inside the program. And anyway, here's the implementation of these. but it's got a load bitmap function, or BMP function, so it can load file bitmaps, and basically it has the net result of those structures automatically being filled. But he's using a command called fopen to open the file, and assigning this signature array. I'm not really totally sure, without thinking about it, what he's doing. I hadn't looked at this for a while. Hold on. I know even though we're loading D3D11, it doesn't work because he uses D3D9, and that's why we're not using this at all. Basically, I'm not using this at all in my program, because the D3D methods don't work. D3D9 will not work with D3D11. That's much different, apparently. So since I don't have the SDK for D3D9, it just won't run the code. So okay, to load the bitmap, here in game.cpp, in the constructor part of it, we're going bitmap1 equals load bitmap. We're calling that function in the bitmap file here, and this is the name of the bitmap we're loading. This is the file header, and this is the bitmap info header. Now in the game.h file, I include the bitmap.h header into this, and then you can see I created these two instances of those structures, the bitmap info header and the file header type. And I don't know if I created that or not, but this is something I created right here. Pixel 24, which is a pointer to bitmap 1. So, well, I don't know if I created that or not. Well, maybe I did. I don't know. Pixel 24. Oh, yeah, here we are. There's a declaration to it anyway. Now that's just the definition of our function, that loads the bitmap. But here's the Pixel 24 structure, so it consists of RGB pixels. Then it basically, this is the definition of our other function, our load bitmap function, because these just define structures. Okay, 3 different structures, and there's no class in here or anything. And here's the only function in bitmap.cpp. It's the only function we have. So, so anyway, in the game CPP, it calls this function, passes in our file name, the structure, and into structures, basically, for the file header and the info header. Okay, and then it goes file, BMP file equals fopen file name RB. I'm not sure what that means because I don't remember what the syntax of this is. I think that's binary. Read binary is what I think it means. So it's because it's a binary file. Bitmap's a binary file. I'm going character signature 2. Okay, and what he's doing with that is creating a character array. Okay, because we're looking for BMP files are titled with something that says BM, at the top of it, the top of the file. So that's a dead giveaway that it's a BMP file when it says BM at the top. So an fread means file read. So signature So it's going to read 2 characters in, since we're reading it into this structure here. And when we're passing this structure, without brackets on it, it's like a pointer. So it's acting like a pointer because there's no brackets on it. So we're really passing at a pointer to that structure, and going size of character, comma 2, I guess for, I don't know, two characters, and then the file name that we're going to read from. So, which is defined here, bmp file equals f open. So, so it's telling us what file it's in, and I guess that we're going to read 2 characters, but it'll grab 2 characters from it, and then, we're checking to, with this assert statement, and this assert statement is just for debugging. This doesn't make it into final code. This is Chili. He likes to be fastidious about things like that, so it'll throw an error if this isn't the case. But normally you'd want to put proper error handling routines in it, not something that only functions in the debug version of the code. You want something that will function in the release version of the code. This won't. So assert is really not something I'm probably going to mess with that much. Not unless it starts to become a real issue, but normally I'd want to have actual error handling code in my code. So, not something that's temporary like this is. But then we're doing an fread file header, so we're passing it our structure, the file header, which you can see over here. So it's going to get the file size, which is an unsigned int, unsigned short, or reserved 1 and 2, so it's got 2 reserved spaces, and then offset to pixel data, which is an integer. And so it's going to, pass it in an address to that structure. It's a reference, address of file header, and size of file header, which will get, how big it is, how big that structure is, and then 1 unit, I don't know. I guess we're going to read in, 1 copy of that. I'm not sure. I don't know why we didn't do that up here. But then BMP files are file name. Okay, and what that'll do is that'll actually populate the whole header automatically, and apparently and sequentially, because we did the same thing here, to pass the info header. And the info header has a lot more data in it. You can see if we're getting, header size, width and height, planes, bits, compression, image size, the X and Y resolution, number of colors, etc. But that's the whole header of a BMP file, and just by passing it into this, using the fread, it was able to extract automatically and populate those fields properly. So the funny thing is, you didn't have to do it manually at all. I would have thought he would have had to gone through it 1 byte at a time, or 1 element at a time, and make sure it ends up in the right place. But apparently it reads that structure as you wrote it and applies that to the in the order you wrote it, and extracts data that way, because it couldn't possibly know it's a binary file. It's just 1s and 0s. It really doesn't know where everything is. It's up to you to tell it what a given position in that file means. So, because it doesn't just know automatically. There's no fields in a binary file. It's not like a comma delimited database or anything, So, but then we're doing an fseek, and we're using the offset pixel data member of the file header, that we've extracted, to find out where the start of our array is, or the actual bitmap data. Okay, at that point, that's where it starts to get interesting, because then we go number of pixels equals info header.width times info header.height. So again, that's the number of pixels they have, and we have 3 byte pixels, although the funny thing is that supposedly these are padded. They're supposedly 4 byte pixels, but for some reason we're able to get, and I still don't know why this is. For some reason we can get away with it only having a three members defining our pixel structure. I was sure this was going to throw up an error, but or cause garbage on the screen, but it actually worked. So I don't know why, but supposedly pixels are stored as 4-byte pixels. One red, one green, one blue, and then one alpha, or just not used buffer. So, but it does work. I mean, they seem to be either packed right next to each other or something. But anyway, then we're going pixel array. And like I said, I'm creating, an integer of pixels, int called num pixels, and I'm making it, our width times our height, so that's the number of pixels. Okay, then I'm calling info array. I'm making a structure pointer of type pixarray. I'm calling a variable pixarray, and then I'm saying equals new pixels 24, and using number of pixels to declare the size of our array. So I'm making an array in the heap because it's just I'm using the new keyword, so that means it's always on the heap. Whenever you see new or delete, that means it's on the heap. So it's going out in the heap memory and making an array, which could be gigabytes in size, if you wanted to have it that big. But so you could upload very big bitmaps into this, but it's going to be the size of the number of pixels, and that bitmap you saw was pretty big. Anyway, then I'm going, we're doing a for loop, saying for index equals 0 to I equals number of pixels minus 1, and then index is less than equal to number of pixels. So I'm using two variables here, and this is because, again, the fucking thing will come in backwards and mirrored. If you don't do it this way, it'll come in like upside down and then mirrored. So I got to undo that, and that's why this code is so complicated to read it in. Because originally it was a really simple code, until I realized the bitmap was backwards and mirrored. So, or upside down and mirrored. So, making it right side up was easy, but it was still mirrored. I just had to count backwards to make it unmirrored, but really I had to go do this index thing and then try to flip these pixels all around, using this rather, brain twisting algorithm here a little bit. But at any rate, it populates that array on the heap, and then we close the file and return pixel array, because that's the return type of our function. So, it's just a pointer to pixel, but, since we're expecting a pointer to be returned, well, that's what we're returning, is a pixel array, which is fine. It doesn't matter if it's pointing to a single variable or a whole array of variables, because pointers are pointers. They can point to anything. Like I said, that pointer could just as easily have been a pointer to single integer as as to a gigabyte or sized array. So anyway, it returns that to our game program, which basically has to set the number of pixels too, because this has got to be a local version of that variable. That's what got a little tricky, is having to work with these structures, but where do you declare them and all that? So that was the trick, is having to declare it over here in these classes. So, and that's why this is part of the constructor too. It's one of the first things we do, but this doesn't have to be located in the constructor, but it just does as part of the startup code if you want it to show up immediately, like I have it. So as soon as you run it, this bitmap will show up in the background. But at any rate, this just takes care of a variable. Since now this stuff is defined, I can set the number of pixels based on the header, that we sent it. So, that we declared over in the game.h file. So, because we basically declare that over there, that we send the declared version over to our function in our bitmap .cpp file. Okay, but that's looking for an address of. So we're actually sending the variable by reference, but you wouldn't know it by looking at the code. Because that's the nice thing about using the by reference is that from the code standpoint, you don't know that you're not passing by value versus by reference. But it's necessary to pass this by reference because we need one version of the header preferably, because there's no way I could return from a function call not only our bitmap array but also this and this populated too. You couldn't do it without making these global variables. But by declaring a variable over here in the game.h file, and then passing it into our function, well, then they can be populated because they're passed by reference. So they can be populated, when the function executes, and then when this function returns, it not only returns our array, but it also returns this too. Now I could have, in theory, also just declared some kind of an array over here, but remember we got to size it. So that's why this had to return, this function had to return a pixel array, because I can't create an object over here per se, even though we do create this object or declare it over here, right here. I declare it as a pixel pointer. Again, a pointer can be any size. It doesn't just have to be one element, but that's a pointer to a structure of pixel 24. But basically, I had to pass it in, but this thing right here will actually set up the array size over there. But because it's a pointer, I actually probably could have just made this function void return type and just passed this in as a pointer, and it would have populated it as an array, and we could have had the but see, the problem is though is that it's got to still declare the array size in the heap. So no, it has to be passed in this way. Well, I mean, it doesn't have to be passed in this way, because again, we could have just passed it in as a pointer. We already defined it here. We could have just passed it in as a parameter and had our function return void, because it'll go ahead and set up the array size, in memory, because it doesn't matter, because this pointer doesn't care. It doesn't care if it's pointing to an array or a single structure, just as long as it's pixel 24 in size. That's all it cares about. So yeah, we could have done it that way. Instead of having to return having a return value from the function. So we could have just, instead of saying equals, we could have just had this in here, so it just calls it as a, an outright function, and with a void return type. So we could have done it that way. We didn't have to actually use this assignment. But again, I'm still trying to get the feel of this whole thing, because I'm just not even used to functions, honestly, from my Visual Basic days. Because I didn't use functions like this too often. I mean, I used usually global variables in Visual Basic, so I never really worried too much about parameters and return types, not all that often. So even that's kind of new to me as a coder. But let's see, number of pixels, width and height, that's taken care of, and then we go down to our compose frame member function here. Not that, but this right here. This is where we actually print the bitmap. So draw our bitmap. So, and this is how I go through and do it. So red, green, and blue, so that's where I'm putting the, I'm accessing our red dot bitmap 1, our bitmap 1 I dot red, bitmap I dot green, and dot blue. So this is where we're accessing color for a particular pixel. And since this is a single dimension array, I have to work this math right here to, index into it. We're still working with two indices. Again, this would have been better really just to implement it as a two-dimensional array, which I could have done. so I would have moved a lot of that work into the other location. And in fact, I think this would have been an easier function to figure out if I would have made it a two-dimensional array. And there's really no reason not to, because Chili doesn't like the idea of two-dimensional arrays. He thinks that creates more work or something, but it really doesn't, because it doesn't matter whether you're doing it manually or C is doing it manually. The code's going to probably come out pretty much the same, I would think. But maybe not. But but I would imagine that the compiler is smart enough to optimize it. Optimize the statements out of it so that in the end, because in the end, in memory, there's no such thing as a two-dimensional array. It's all a one-dimensional array. But but the compiler has to go create arrays just like this. In the end, it's single-dimension arrays where you take care of the indexing, of the width versus length, yourself. Okay, so but you can do it manually like we're doing here, or you can just create a two-dimensional array, and the compiler optimizer will go ahead and take care of that. But in the end, it should end up the same, but it's easier to read the code this fucking way as an XY matrix. I mean, in the end, if you're looking at code readability, a two-dimensional array is a lot easier to read and understand than a one-dimensional array where you're having to do all this math in your head to see what's going on. It just, I don't know. I mean, to me, I'd always just use two-dimensional arrays or three-dimensional or whatever. I mean, that's how it does. That's how mathematics works, and that's how linear algebra works. You're dealing with arrays. It's kind of silly to go do it the hard way. There's no good reason to go do that, as far as I know. I just don't buy the argument. I mean, I'm interested in the argument, but I'm not buying it, and there's just no way I'm ever going to do that. At any rate, this takes care of drawing our bitmap, and that's how that fucker works. So that's good enough for this video.